How's everyone doing today? So we're here to talk about what it's like to migrate onto DBT, some strategies you should employ to help you make the most use out of DBT and set you up for success. So we'll start by introducing ourselves, and then we'll go through all of the different things around why people are migrating onto DBT, what sort of issues people have run into before, and how to avoid those things, how you're going to do those things right, and then we're going to open it up for questions. So, Chris.
All right. So I'm Chris Johnson. I'm a solutions architect with phData. I started my career in software development, but quickly kind of gravitated toward the database and designing database solutions and optimizing database implementations, and then working through a bunch of migrations, both on-prem as well as to the cloud. And one of my life philosophies is to surround myself with people who are better than me, which is what led me to phData a few years ago. And now I get to work with great people like Dakota.
Thank you. So I'm Dakota. I'm a solutions architect at phData as well. I do all things DBT. I take care of all of our DBT content. If you've ever read anything we write about DBT, our thought leadership, I train our teams. I teach them how to effectively use DBT. I come in and help customers that are really struggling. I come from a higher education background where I worked as a software engineer in higher ed for about 8 years before transitioning fully into data. Did that after earning myself a master's while working full-time, which is a whole different story that I'm not going to bore you all with. Okay, so why should you even trust any of our advice? Well, first off, we have done well over 40 migrations between core, cloud, small shops to extremely large enterprises, and we've seen that there are common patterns regardless of the size of your implementation, the size of your organization, or which one you're using, that are common, and following these practices are going to set you up for success. So I'm going to pass it to Chris to cover why people are migrating.
All right. So typically what we've seen are three main drivers for people to choose to migrate from older legacy technologies to more modern tools like DBT. And the first one has to do with the lack of governance support. So we see this a lot where older legacy tools did not have the same maybe advanced security options or capabilities around regulations and compliance and things of that nature. And in this day and age when so much emphasis in our organizations is being put on audit and compliance, it just has elevated the need to have these kinds of capabilities in tools, hence the need to move to something newer. The second reason is a lack of automation. So we've seen this a lot too, where legacy tools did not have the same automation capabilities, and in the absence of those automation capabilities, what do? Well, we either build manual implementations or we bubblegum and baling wire something together to try to make it work. All of which just ends up being brittle. It doesn't perform as well as we would like, and you've got the reliability issues with that. So that's another driver to more modern technologies. And then the last one is they're just difficult to adapt or customize. So legacy tools generally, historically, have been very black box. They don't provide a lot of insight into how they work, how they can be extended if you need to extend their capabilities, or if something goes wrong, how to effectively figure out what in the world is going on. And so, again, with tools, the legacy tools, this hurts us because if we can't figure out what's going wrong, or if we can't figure out how to extend a particular tool, then that puts an unnecessary dependency on the vendors for their support, which of course they'll charge us for. So those are drivers to move off of legacy tools and technologies. And modern tools like DBT have been designed with a lot of governance features built in, a lot of automation capabilities like RESTful APIs, webhooks, et cetera, a lot of integrations with third-party platforms, and they've got that much more transparency around it. I mean, with DBT Core in particular, you understand exactly what's going on, all of which leads to being able to increase our team agility, the implement data pipelines that are more performant, provide better access to data, provide higher quality data. But there are pitfalls that we need to be aware of. Now, thankfully, they're not quite like that. That looks a little dramatic, and that's probably more like a game over pitfall. But there are pitfalls. So part of what we want to do is just make people aware of some of the pitfalls that we've run into. So with some of the migrations that we've done, they kind of fall into three categories. The first one has to do with treating modern tools like legacy tools. Now, we just talked about how DBT and other modern tools have all these great new features and functionality, but if we don't know what they are, if we don't know how to take advantage of them, then we're not going to benefit from them. So I am kind of a hack photographer, and one of the things I like to do when I get a new camera, which I don't do often enough, but when I get a new camera, I like to lay in bed at night just poring over that user guide because I want to understand, how to take advantage of all the cool things that this new camera can do. And it doesn't mean that I can't take pictures with the old camera, because I can, but I'm not going to be able to be as effective and use it as if I read the manual. Now, I'm not suggesting people lay in bed at night reading the DBT docs, but should you read them? Yes, definitely. Should you read the release notes when they come out? Of course. And when you're interested in a particular feature, do a pilot on it, understand it, how does it work, so that you can then take advantage of those features. Because if you don't take advantage of those features, you're never going to benefit from them. So the second is not changing your paradigm. And there are a lot of paradigms that come into play with how we develop our data pipelines and our data solutions. One of them is just, historically, pipelines have been very procedural in nature. You do A, then you do B, then you do C. They're rigid, they're defined, they're very static. Tools like DBT and most modern tools tend to be more declarative in nature. So instead of telling it, do A, B, and C, you tell it, what do I want out of this? At this step, with this model, what do I want it to produce? And we leave it to the tool to figure out, okay, so what are all the dependencies that are going to get me to where I need to be to produce what you want it to produce? What do I need to do in that data layer to do that? And so that's a paradigm shift, though, that we need to make. We can't come into modern tools with some of that old thinking. Another example is ETL versus ELT, right? A lot of historical tools, our data pipelines were written extract, transform, load. And a lot of that was because the tools that we were using and the resources we had available were fixed and limited, and we wanted to conserve them as much as we could and make the best use of those resources that we could. And so we would set up these staging areas where we would pull the data into a staging area, we'd do what we need to, and then we'd put it into an area where it could be consumed by others. Modern tools, we've got the dynamic allocation of compute, of storage. We're not limited in the same ways that we were before. And it's actually more effective now for us to do that, extract, load, and then focus on the transform. So that's another paradigm shift that we need to make. So again, can't come into it thinking the same way as we have before. And then the last one I'll just call out is just modern development practices. Right? So software development has typically led data engineering in terms of adopting good practices like code reusability and coding standards and automated CI/CD pipelines. But we're there now, and there's absolutely nothing that should be holding us back from adopting those same kinds of practices in the solutions that we're developing. So just another paradigm shift that has to happen. Did you have anything on that one?
No, I think you hit it all.
All right. And then the last one is the lift and shift with no refactor. So how many of us have developed a data pipeline or developed anything, and 6 months later, even a month later, come back, it's like, I could have done that a lot better. I wish I would have done it a different way. Yeah, we've all been there. And all that stuff is still there. And when we do a migration, we have a choice of just lift and shift and bring all that crap with us, or do we take the time to refactor our code? This is a great opportunity to refactor, to deal with the technical debt that may be there and come up with something that's not garbage in, garbage out. All right. So how do we avoid these problems? So in a nutshell, you need a strategy. Adopt a sound migration strategy. Now I'm going to highlight just 4 things that we have seen needs to be a part of a strategy. You can come up with other things as well. You ask the person next to you, I'm sure they'll have ideas on other things that you should include in a strategy. So the migration strategy is just a plan. And we've all heard, failing to plan is planning to fail. That is definitely true. The whole goal here isn't that you're going to come up with a plan that is going to be perfect and totally get you through your migration. It's going to cause you to think about these things. And that's really what this whole session is about, and what the migration strategy is about is let's give these things some thought. Once we get in them, maybe that initial thought wasn't exactly working out the way we thought it would, but at least we've gone through the effort, we've thought through, and now we can pivot to something else if we need to. The first thing is to plan the model evolution, refactoring versus modernizing. There are a lot of ways that we can attack refactoring our legacy data pipelines into modern data pipelines. One would be just to do in-place transformation where we maybe carve out a particular data flow or a set of data flows, and we re-implement them in the new tools and technologies and replace them in place. Now, that tends to be pretty easy to do that in terms of actually implementing the new data flows, but they can be hard to validate because you don't have a good reference point to validate from. As well, you don't have to do all of the same setup that you would do in some of the other options that we'll talk about in a sec. Another approach that you could take is a parallel approach. So where you do more of an alongside, take that same set of data flows that you want to implement and implement them in parallel. So with this model, you still have to have 2 systems operating, right? So there's more resources, it's going to cost more, but you've got a good reference point for validation this way. It also tends to be a little bit cleaner for our end users to validate against. Maybe you choose to adopt a hybrid approach. So maybe for some of the simpler, more straightforward data flows, you just do an in-place refactor of those, and maybe the more mission critical, you decide to take a parallel approach where you stand them up and have both of them running in parallel. Again, there's no wrong answer. You need to decide as an organization for the risk appetite that you have, what's the best strategy for you in what you need to migrate. Anything? Okay, keep going.
Yeah.
We're on a time crunch here. So adopt and follow Git best practices. So this is another thing as part of a data strategy, and again, data engineers have not always been at the forefront in adopting good Git practices and development practices. Figure out what you're going to use as a code repository. How are you going to do branching? What will your branching strategy be? Are you going to do release branching, feature branching, whatever? Think that through, make that part of your strategy. How will code be migrated from environment to environment? Will there be approvals required at certain stages? And if so, who's going to do those approvals? Implementing CI/CD pipelines, leveraging Slim CI as part of DBT. All those things should be thought about and be part of the migration strategy that you put together. All right, leverage proven architecture and structural approaches. So typically, when setting up your DBT project, what we like to recommend is that you organize it in a way that reflects whatever your maturity stages are. So if you follow a raw, cleanse, curate type staging, or maturity stages, or bronze, silver, gold, or maybe you've got source and product, whatever it is, structure your DBT project to reflect that. That makes it a lot easier for everyone to find the components because they align with the maturity stages that you've already adopted as an organization. Another thing to think about is the repository itself. Are you going to go with a single DBT repository, which is certainly a good place to start and works well up until you get so many models in there that it's really hard to keep track of whose is whose and what does what. So maybe a multi-repository approach might make sense at some point. And then certainly with the newly announced DBT mesh features, you could do that even more securely and safely, sharing models across teams. Keep going?
Yeah.
All right. So the last thing that I'll highlight is part of your migration strategy to include validation and auditing as part of that. So it's very easy for these things to be more of an afterthought than an upfront planned for. But put in the effort to include it as part of your strategy. Think through how are we going to validate and where do we want to validate. So as we think through the data as it moves through the new pipelines, at what stages do we want to validate and what kinds of validations do we want to do? Do we want more coarse-grained table-level type validations? What are the metrics that are important to you? Or do you want more detail-oriented, maybe at the column or row level metrics? Again, it's not a right or wrong answer here. It's for you as an organization to figure out what makes the most sense for you and then to include that as part of your plan. I would also recommend involving end users in user acceptance testing of the new pipelines. They're the ones who are consuming the ultimate product. They will appreciate and have more trust in the solution if they're involved in the planning of the validation up front. Anything else? Nope.
No.
I'm going to pass it over to Dakota.
So, much like you said, in short, we want to embrace the evolution of our field. We want to become more software driven. We've seen all these practices excel and help those who work within software development. We need to bring those to the data community as well. So I'm going to talk about, okay, well, how do we do that? That strategy's fine, but how do we accomplish that? The first thing is, as we talked about, you want to pick your architecture, whether that's data mesh, whether that's a mono repo, whether you're doing data vault, Kimball, whatever modeling style, whatever project architecture and structure you want to go with, spend time deciding what that's going to be and enforce those best practices. And the way you do that is you can apply meta testing. We're all getting excited about just testing our data quality and making sure our data is available, but it doesn't have to stop there. Once you've architected how you want the system to function, how you want people to name things, how you want people to structure your project, apply meta testing. Use the DBT project evaluator. Use these things to optimize and catch these things, because as you're first getting your hands on Git, especially if you've not used Git before, it can be intimidating and it can be hard to know, okay, am I reviewing code correctly? If you start to test these and make these a part of your CI/CD process, they get tested automatically for you. You already know, oh, someone didn't follow our naming conventions. We're not merging this. You got to go fix those. By codifying that, you make your job easier, because you're not even going to look at code until all the tests pass. And you're testing not just the data quality, but the structure of your project as well. Another way to do this is to also spend time centralizing your artifacts. DBT generates a massive amount of artifacts. Tests, what was the success failure rate of them? When did they run? When was the last run? When was the last run of X model? You can centralize all of those artifacts with the DBT artifacts package, and now you have a way to visualize how is our DBT project running? Do we see a source is failing regularly? Maybe on the 15th of every month, okay, we need to talk with who's ingesting the data and find out what's going on. Why is our system having a hard time getting fresh data on the 15th? You can start looking at these and holistically be like, what's impacting our system? Where are the issues at? And how can we start being more prescriptive about what work is important? Next, start following testing and data quality best practices. And that's not just implementing tests. We all look at this as, okay, we're just going to implement a bunch of tests. That's a good starting point. You want to get in there, start simple with some foreign keys, primary keys, stuff like this. Over time, though, you want to decide, how do I want to test? And what are the best ways to test? In our opinion, the best ways to test are to test very heavily at the front. Test on your source system. Make sure the source data is fresh. Make sure the shapeness of your source data is the way you expect it to be, the way you expect the data to be connected. Focus on that. In those intermediate layers, maybe some lighter testing, and then that final data model needs to be heavily tested as well, that it meets your business requirements. This allows you to get a good balance and good flow to avoid alerting fatigue. Last thing you want to do is build a test for everything and then have your team be on pager duty getting called every night at midnight because some test failing that doesn't actually matter, doesn't need to be there. It's a good way to burn out your engineers and have a hard time finding new ones. Spend time auditing. There's a lot of different ways to audit, and there are useful tools within DBT. You have the DBT audit package. If you're doing an alongside migration, maybe you start with a lift and shift. You don't have time. Your Informatica contract is running out, and you have 2 months. You lift and shift, and then you start modernizing. Okay, you have those both in your DBT project. Use the DBT audit package as you build out new final models to make sure that the new model matches what the old model is. Make sure it's got the same data. Make sure things aren't missing. You make use of data diff tools to make sure that as your team's merging changes, you're not suddenly missing 20% of your data because all your tests passed, but you didn't recognize that suddenly you lost a huge volume of data. And come up with a verification and validation process. This can help you figure out what things need to be tested and what your business users expect. With this, you're connecting with your business users and being like, what do you expect out of the data? How should we be verifying and validating that your data is correct? It's easy for us as engineers to think to our roles around third normal form, star schema, et cetera, but that doesn't matter to the business. The business cares about, oh, I want my data to look this way. I expect these type of values. If you're not testing for that, you're not making sure their dashboards are correct. Top of that, take use of DevOps. Build in automation. Decide how you want people to write SQL within DBT and start linting, start formatting, automate that. Make it as easy as possible for people to write how they want, but at the end result is that it all looks the same, so everyone is writing their code in a formal language, so it's easy for everyone to read. We've all been there before. You get a SQL file from someone who writes SQL differently. Maybe it's leading versus trailing commas on your columns, and it just infuriates you. Decide as an organization how you want these things to look and automate it. We get these things with SQL format, SQL fluff. Make use of CI/CD best practices. Automate your CI/CD. Build those into your Git repository. Use Slim CI to optimize your runs. Save yourself money and time. And don't forget to take advantage of advanced deployment practices. Based on your industry, based on what sort of time constraints and other things you have, maybe something more like a blue-green run is what you need, where you run everything in test and then swap it right over into production as soon as you know it's good. Focus on branch protection. We got to think about Git holistically. The last thing you want is a rogue engineer merging right into main because he didn't feel like waiting for a PR to go through. Protect your branches appropriately once you've decided whether you're doing a release cycle or whether you're going to go with more of a feature branch style. And create PR templates to make it easier for you and your team to know, okay, here's what's been worked on, here's what's changed, this is what I need to review. Because nothing's worse than getting a PR that says, fixed some code. Make sure you spend time thinking about FinOps. At the end of the day, as we build out these systems, as we're making use of these transformations, it is our due diligence to make sure that we're not just spinning transformations for the sake of transformations. We need to think about how do we optimize for our data platform? How do we make sure that we're not doing unnecessary spend? Because the less we're spending as data engineers, the more consumption there is for people like our data scientists to start looking for something that can actually bring the business value. The more room there is for your analytics teams to do bespoke analysis and find maybe a new trend you are missing out. If you're wasting all of that compute just sitting there transforming things that don't need to be transformed, maybe there's no fresh data yet. Maybe you're running models that have no reason to be run. You're just wasting some of that compute. And finally, we don't just want to tell you what to do. We've got 2 repositories here of DBT projects set up. They have SQL fluff set up. They have a Python script to call the DBT API and pull for success. They have a GitHub action that will automate upon merge, running your new code into production. They have these modeling standards. They have the DBT project evaluator configured to work for either a data vault model or a dimensional model. They've got these configurations so you can see what best practice looks like and get your hands on it. So when you get home and when you're thinking about how you want to architect, how do I implement these within my DBT project? Any questions? I know that was a lot of information.
What FinOps stands for?
FinOps, finance ops. It's a way to focus on making sure that we are being responsible with our spend. We're all working with cloud systems now. That means we're not having to manage hardware. That's great, because if you need a bigger resource, you can get it. But it's also possible for you to think you need a bigger resource when really you should have maybe optimized some SQL instead of using the largest warehouse available.
Or to not be aware that there's a huge spend going on in a particular place that you just weren't aware of. The data's there. If you look into it, you can find it and know, okay, yeah, this is an area that we need to cut back.
This becomes a big part of observability. The more you look into your data platform, how is it being used? Where am I spending money and why?
Yeah, and if you don't have observability as a part of your platform, you need it. Yeah, unless you've got very deep pockets and don't care how much money you're spending, which is not most of us.
Is there any practices about freshness driving the schedules of your job?
Yes. Yes, so there's actually source freshness. So as you bring in sources into DBT, what I recommend most people do is any data that's landing, you want to document when that data lands. You can build source freshness tests off of that and then use Slim CI to say, I only want to run models who have a status fresher than the last time I ran, and make use of that artifact tracking.
That's pretty cool, I would say, but we have like recurring jobs that are scheduled. Rather than doing that in Snowflake, we could run the query history and look at the last modified table and then kick it off.
Yep, exactly.
Rather having it running and using cycles and a Snowflake.
Yeah.
Right.
That's pretty neat.
Any other questions?
How do you know, you mentioned testing at the beginning, doing a lot of that there, at the end, doing a lot of testing there. How do you know in the middle what's sufficient enough where you're not over-testing but not under-testing? How do you find that?
That's where you have to kind of get back with the business. That's where that validation and verification process comes in. Now, there's some basic things you can do, making sure that if you're setting up, let's say you're doing some hashing to make some more efficient joins between certain keys, or make it simpler to join because you're taking, a multi-key product and turning it into one hash key. Do things like making sure that those hash keys join correctly across the tables in your intermediate layer. You can think about this more from that database perspective, that database architecture style, but also this is where you want to start kind of leaning into your business and find out, is there certain things they're expecting? Is there certain ways they're expecting things to be calculating? Maybe you work with finance and in the transactional team, they don't want to store negative numbers, so you have a debit and credit indicator and just the dollar amount. But maybe in their report, they want it to either be a positive or negative. Okay, we should see values that go under 0 because maybe there's been a debit or credit that's causing the negative and vice versa. You want to start kind of maybe implementing those in that middle layer because you're not going to have that at the source, and you shouldn't be updating the source, but in that intermediate layer, you're starting to make that change and you want to make sure you haven't done the wrong change. Maybe it's as simple as checking the roles, making sure that you're applying the debit correctly or the credit correctly and applying that correct negative or sign flip.
Do you have any idea how to check the data quality of a sequence? Like if data comes as depending sequence of records, how to check the validity of the sequence that you're streaming in? And that's real-time data that you're going to display.
Checking the quality of real-time data is a very interesting challenge. This is when you're starting to get beyond just your basic data testing. You're starting to get into your statistical testing. You want to start monitoring for, okay, what sort of deviations am I seeing? Do these deviations make sense? I mean, even when it comes to those sort of chains, you might even start leaning into like Markov chains and some other stuff to see if there's any sort of sequence breaking. That's where you want to start relying on your advanced statistical checks. You can start off simple, but when you get into those cases, that's not easy to do in a simple SQL. You need your statistical analysis.
So like have something running on the,
I would make use of Great Expectations, which is built into DBT. There's DBT expectations. Save yourself the time from standing up Great Expectations. Any other questions? Yeah. Mm-hmm. There's a lot of different ways to communicate that. I think it depends on how you're also catching those. If you're using something like DBT's audit tool where you're doing a comparison and you're finding those, if the issue hasn't made it into production, then you just need to start an email chain, Slack message, whatever, with whoever and figure out where things went wrong. Maybe something has gone into production. Hopefully you're making use of some sort of automated data diff tool and you can make that a part of that system. But really, the best way would probably be to hook up some sort of notification to Slack, Teams, whatever. We've got these webhooks now. Make use of that to say, okay, we're merging, and try and get as much information as possible. Maybe even hook it up to Git so that way that the reason for a merge or a change to code is getting out there and so people can see, oh, here's the change. If people are following proper PR requests, they know why a merge is coming in. They know what data is being changed. You should still try and reach out to the business, but depending on how big your business is, the last thing you want to do is try and pick up the phone and call all 400 people in finance to tell them you're changing something.
Yeah. And I would say that a migration is just like any other project that we do. And as part of good project management practices, we should include a communication plan. So even beyond the issue communication and automating that, all of the other aspects of communication between the various parties involved in the project, I think setting that plan forth, right from the start and making that part of the overall strategy is a good call.
Fantastic. Any other questions? I think we have time for one more. No? All right. Well, thank you all for your time. Hope you guys found it insightful.